Good morning, Evan. Welcome to lesson 4. So, in our last lesson, we started with animal nutrition. So, this lesson, we are specifying with human nutrition. So, human nutrition, it seems really simple. I mean, you're a human, you know what's going on, but there are a lot of big words you need to learn. But once you put them all in a process, you will understand it better and it'll be really simple in comparison to all this busy stuff going on in the book. Okay, so the digestive system, that's what we're going to start with. So it is responsible for the process of nutrition, but not assimilation. It is made up of two things: alimentary canal and your accessory digestive organs. So your alimentary canal is a continuous muscular tube from your mouth to your anus. It's where the food it flows through. Your accessory organs are the organs like teeth, tongue, and glands, liver, and pancreas. They help in the process of digestion. So it's a really lame example, but for example, in an outfit, an accessory helps the outfit, an accessory gland helps the digestive system and the alimentary canal. So then on page 120, you've got your diagram. You need to learn of your accessory organs and your alimentary canal. Then you've got your digestive system structure. You also need to learn on page 121, but we're just going to discuss it. So we're first going to start with your liver. After your skin, which is everywhere, your liver is your second largest gland. Its nutritional functions are it makes bile. So bile's in your stomach and it's stored in the gallbladder. Bile helps to break down the nutrients in your stomach. Processes absorbed food. The liver processes absorbed food, regulating the amounts that are allowed to enter the general circulation. So not everything you eat enters your general circulation. Some of it's not good for you. Some of you've eaten too much of it and your body doesn't need that much, so it would rather pass through than give your body too much of what it needs. Remember, your body needs a happy medium all the time. So it won't add something to your body that will throw it off and make it ill or send chemicals to an imbalance or hormones to an imbalance. It will want to keep it at a simple medium. Glucose, so for example, glucose molecules combine by condensation synthesis to form insoluble glycogen, because we don't want soluble glucose, we want insoluble glycogen, which the liver stores. Glycogen is an ideal storage molecule as it is osmotically inactive. It does not move through water. It stays solid, glycogen. And amino acids combined during condensation synthesis to make plasma proteins called globulin and albumin. So the liver makes vitamin A from carotene, breaks down alcohol, drugs, and hormones. It forms cholesterol from certain fats, and it stores fat-soluble vitamins A, D, B12, and iron. So for example, that's why when people drink a lot or take lots of drugs, they are affecting their liver, because only this organ, this poor little organ, needs to sort out all those bad substances that you're putting into your body. So if you take too much and constantly, your liver gets almost tired and it can't cope with the amount that is entering your body of these harmful substances. So it affects your liver. And cholesterol, if you eat too many of your bad fats, such as chips and sweets, and you can get a buildup of cholesterol. And that makes your arteries smaller, so your blood can't flow through as easily, and that's how heart attacks can happen, for instance. So your liver is important. It helps a lot of things and regulates a lot of everything really that enters your body. Then you have your gallbladder. This is a muscular bag found on the undersurface of the liver that stores the releases bile when necessary. So its nutritional functions of bile. Bile emulsifies, so it breaks down large fat globules into fat droplets. So now these are easier to process. Anything smaller will be easier to process than something much larger. This helps the digestion of fats by increasing the surface area on which the enzyme lipase can act. Bile provides an alkaline medium for the action of enzymes in the pancreatic and intestinal juices, and it helps the absorption of fat. So we need bile. So therefore, we need a place to store bile when it's made in the liver, and therefore we need our gallbladder. Then we have, how is the gut supplied with blood and lymph? It's supplied with oxygenated blood from the aorta. The blood leaving these organs takes absorbed nutrients in the hepatic portal vein to the liver. Lymph vessels carry fats away from the gut. The lymph with fat finally enters the blood in a vein near the heart. So the liver is also taking part in that process. Now we have digestion. Why does food need to be digested? That's a very simple question. If we don't break down our food and get the nutrients from it, we won't get the nutrients. And then what's the point of eating the food? So it needs to get into the body, it must be broken down into small soluble molecules and can move through the walls of the gut into the blood plasma or lymph stream. So it needs to be broken down, which is the process of digestion, so that it can be absorbed. Physical digestion. So this is the physical acts that help during digestion. So how do you get the big piece of food into small soluble molecules to be absorbed so that the chemical part can then go in and further break it down? So we have chewing. That's your first thing. You put it in your mouth and you chew your food. Teeth are well suited for biting, tearing, and grinding food. And they have different shapes for different types of food, as we learned in our previous lesson. Tongue actions, pushing the food between the teeth so it helps you chew your tongue. Mixing the food with saliva. Saliva is an enzyme that further helps break down your food and make it into smaller molecules. And mixing the food with saliva to form bolus, a compact mass, so the thing you swallow, and it pushes it into the pharynx, the back of your throat. So you could have your teeth, but without your tongue, the process wouldn't work. Then you have peristalsis. This is a reflex action. It's a movement, which is triggered by the presence of the food bolus in the pharynx. So when your food bolus is in your pharynx, which is the back of your throat, the peristalsis goes, oh, it's my turn to start working now, and starts. The food moves from pharynx to anus through peristalsis. Peristalsis is the alternating waves of contraction and relaxation of muscles in the gut wall, causing a ring of constriction behind the bolus, resulting in food being squeezed forward. So it squeezes and then it moves and then it contracts and then it squeezes. So it's doing opposite like that. Okay. Churning in stomach is a further physical helping factor, further physically broken down by the strong muscular contractions of the stomach wall until it forms a creamy fluid called chyme. So that's our physical part of digestion. It is everything physically helping our food to break down into smaller molecules. But now we have chemical digestion. So as much as you need to break down into smaller molecules to be absorbed, that absorption still needs to be broken down into the nutrients for your body to absorb and have and take advantage from the nutrients. So how do hydrolase enzymes work? The food molecules fit into the active site of hydroenzymes. So it's like a puzzle piece. The food molecules fit into these enzymes. The enzymes supply energy for breaking up large food molecules into smaller ones by the addition of water. They need water. All enzymes have to work in a specific pH, and we know from previous lessons, temperature. We did this in photosynthesis. If enzymes don't have the correct pH and temperature, they will denature and then they don't work anymore. After the bonds are broken, the smaller molecules leave the enzymes. The enzymes are changed so they can break down other food molecules. So on page 124, how a hydrolase works, you can see it's like a little jigsaw puzzle. One jigsaw piece takes in the other, but then it breaks it down and releases it so another one can come. The hydrolase are found in digestive secretions, so saliva, gastric, pancreatic, and intestinal juices that enter the gut and mix with food. They're needed to break down food, so you're not going to find them in the heart where food isn't being broken down. This is hydrolase enzyme specifically. So on page 125, you have a diagram and a table explaining digestive secretion, what the specific one, where it happens, what enzymes are needed, and the function of those enzymes, and what pH it works at, so alkaline or acid. So you need to learn those off by heart, especially because for activity 4, you're going to very much need that table. So activity 4 is on page 126. That's all I need you to do for this lesson. You'll have 2 activities for your next lesson, but don't stress. I'm very sure you can do it. So have an amazing day, work hard, and send me this when you're done. Well, we'll mark it during our Skype lesson. Thank you.